Hey builders, in this Retro Reacts, we're going to take a look at how Airbnb was looking at troubleshooting and performance testing of Amazon RDS instances way back in March of 2017. Let's get rolling.
Welcome to This Is My Architecture. Today I'm speaking with Shinya from Airbnb. Welcome, Shinya.
Thank you.
Now, normally I'd ask you what Airbnb does, but I don't need to because we all know.
Fair, we do all know. They're in that property reservation, letting you be a hospitality agent, and they still are in that business. Remark on the background, we have a really simple architecture. This is going to be interesting to see how they play through this and what we're actually diving into.
So let's talk about scale. You guys operate at massive scale, don't you?
Yeah.
Huge transaction rates, big databases.
And that was way back in 2017. Imagine what they're doing now, or at least will be doing again now when we finally, if ever, get out of this whole situation.
Yeah.
How do you test those?
Cool. So this is a simplified architecture diagram for Airbnb.
Thankfully, simplified. I figured it would be, but glad to hear the confirmation.
So on the very high level, we have some load balancer, traffic comes in, we're forwarding those traffic into some web machines, then those web machines talking to RDS instances.
Right, standard n-tier architecture, load balancers, web layer, and then into the data backend, which in this case is RDS. Now remember, this is way back in 2017. RDS was very, very different compared to what it is today in 2021.
Over the past few years, we have been seeing tremendous business growth, and we keeping adding web machines into it. Up until some time, we figure out there are some database scalability issue.
Yeah, there's always going to be database scalability issues, especially when you're dealing with a traditional database. The good news is those are well-known problem sets. We know how to scale up. We know how to scale out. Let's see how Airbnb handled it.
That's a time when we design DB replay, trying to test the databases and do optimization correspondingly.
Okay, I like the sounds of this already. DB replay sounds very intriguing. Basically what they're trying to do is figure out where the DBs are breaking and what they can do to adjust for it.
So when you talk about DB replay, you're not talking about just a basic, performance test, run the same query, etc. You've created a system that really replays actual data. Is that right?
Right, that's right.
Talk us through that process.
And that's actually a scenario that's not that hard to set up because of the way RDS does its snapshots, especially in multi-regional ones. You can do that and spin up the actual database, just not connect it to the normal production. So instead of using fake data, you can test this on real data and replay these transactions to see how that would actually interact in production without actually putting production at risk. That's one of the capabilities that's really amazing when you start to leverage it in the cloud.
There are two parts of DB replay. One part is on the RDS side. Every day, we take RDS backup, and then we restore RDS instances in the testing
Yeah, told you.
cluster. So this database contains all the data from yesterday.
So it's yesterday's
Then
production database.
on the web server side, we actually log all the production query in a certain format that can be understood by DB replay. We log all the queries into Kafka. Then on the testing cluster, DB replay has been reading those data from Kafka and then replaying those data back into the restore RDS instances.
Okay, interesting. What they've done here is they're copying all the queries from production and putting them into Kafka to be able to replay them through their custom replay code. Now, the interesting thing is, I'm not sure why they wouldn't just be logging those queries from the database itself, just turn on database query logging, but there's got to be a reason for it. Let's figure out what that is.
Fantastic. So you can drive your workload in a contextual way, but also you can dial it up beyond what the actual original performance profile was?
That is correct. Our typical setting on RDS was one master with up to 5 different slaves. And DB replay able to replay multiple slaves traffic on a single RDS instances. We can set up a test look like starting with 1x of traffic, then gradually increase the traffic to 3x over the next hour.
Okay, that might be why they're not just taking the database logs and they're actually logging it from their web layer, from their logic layer, is because that gives them the flexibility to kind of play around with it to adjust to really, really test this out. Because if you're just simply replicating production, you already would have known if it crashed or not, because that would have been a really bad day yesterday. So this way, what they can do is take those realistic looking queries, how the system is actually interacting with the data, and then adjust and move it around to really put the stressors in specific places to test out their system. And I think there'd be a huge advantages to that, to be able to go, I think we're weak in this area, so the way these tables join together or the way that we've constructed this part of our schema, and then really, really put the pressure to it to see where it's going to bend and where it's going to break.
Wow. So you can tell where your breakpoints are going to be, etc.
Exactly.
I think you mentioned you found an interesting behavior with one of your tests.
Yeah. Initially, when we're testing, we're keeping adding traffic on the restore RD instance. We expect to see the CPU usage grow linearly with the QPS increases. We find out on our databases when CPU hits 30%, if we're adding a slightly more traffic, then the CPU spike.
That's an interesting finding, and that's a finding you're only going to get if you're looking in depth like they are with this system. And essentially what they're saying is there's something triggering here when the CPU hits a certain constant usage rate that it can't keep up, and it starts to fall behind, and that's what with the spike that goes away from that linear progression. And this is the reason why we test at scale. And if you go back to the AWS Well-Architected Framework, practice, practice, practice is one of the core tenets, one of the core principles. It's the reason why we encourage running through game days so much. And essentially this RDS replay machine is a constant game day scenario. So instead of having game day, every day is game day, just like every day is day one.
When we're working with RDS team figure out there is a setting we didn't done correctly, which caused excessive context switches on the database side.
So this is, if it was an RDS setting, this is a really interesting thing because this comes back to the core of the shared responsibility model. Now we know the shared responsibility model that dictates operations as well as security, that you as a builder are always responsible for your data as well as for the service configuration. And in this case, it sounds like Airbnb had a service setting incorrectly, or it was defaulted and that default didn't align with their use case and they needed to override that, which they were able to do because it was their responsibility. But without this kind of thorough testing and the ability to do that outside of production, they probably wouldn't have come to that conclusion as fast as they did.
Fixing that, we see a significant improvement, maybe like up to 3x of databases improvement on our RDS databases side.
So 3x improvement on your RDS database side, not only is that going to be good news for production, that's good news for your wallet. That's going to greatly increase your cost optimization.
Fantastic. So that's a great example of using real data to test because you're finding real world conditions, actual database tuning, etc. How do you manage security? Because obviously this is secure data you're testing with.
Exactly.
So the good news here, though, is that because you're taking a copy of the RDS from production, you can spin that up in a completely sandboxed, isolated account with completely different rules to make sure that only the right people have access to it, or better yet, no one has access to it, and have this in a completely automated scenario.
When the web server logging the production query back into Kafka, we encrypt it. Then the only decryption.
And there's another reason for that custom query format is that they're encrypting it to make sure that they're not logging production data in two places.
Key is available from the DB replay side. So the entire binary data is opaque to the other applications. Nobody's able to access that.
So
that's smart. That's really smart.
Totally secure, but you've got a full event stream that you can run at whatever throughput you want.
Exactly.
Fantastic. Shinya, thank you so much for joining us today.
Thank you.
And thank you.
Okay, so that was a really interesting architecture. And to be honest, the concept is still going to hold up today. Even though this was built in 2017, the core using RDS is still probably viable. Relational databases have been around for 40, 50 years. We know them well. We know where they bend. We know where they fail. And you can work around that quite easily. And if your data is relational in that model, and it's not better suited to something like a graph, which is up and coming as far as that, there's nothing wrong with sticking with RDS. It's a very popular service for a reason. So at this point, you would probably move over to Aurora to save costs if we were redesigning this today. So you'd move it into RDS, but Aurora, because there's some great testing functionality built into the Aurora command line and API as well. The other thing that I would change is I would move their replay machine away from Kafka. Kafka is a little heavy, and I would probably use KMS, so the key management service, and S3 to put the data securely into S3, and then either a Fargate-based container to replay them or a Lambda function. So probably Fargate because the volume, I think, would require a more permanent connection, and that's always easier from a container rather than from a Lambda function. So yeah, let's go with that. I would put the data, take it out of Kafka, put it into S3 with KMS to manage the encryption key, and then I would have a container or a fleet of containers that are running in Fargate that would be able to replay this based on my needs. And again, I would still have this all sitting in its own isolated VPC, ideally in its own isolated account, and have the results then automatically put back into an S3 bucket and graph that with a combination of QuickSight and Athena to move this more into the serverless model because I don't want to be running Kafka and I don't want to be running any more EC2 instances. I've got enough of that in production. So with those few tweaks, I think you'd be able to update this architecture nicely, but the concept is great. Being able to test your database to not just with production data and production queries, but beyond that to really know where it's going to fail. Again, it comes back to those core ideas in the AWS Well-Architected Framework: game days and practice, practice, practice. We'll see you in the next video.